All right, hello everyone. My name is Michael, and with me I have Divya, Simran, Mitten, and Mahir. Me and Mitten are part of the software team, while Divya, Simran, and Mahir are part of the hardware team. We are Team Black Mirror, creating a smart mirror that will have many different functionalities while still trying to remain a discrete piece of furniture that's also aesthetically pleasing. The main functionalities of the mirror will include Google Assistant capabilities, LED backlighting, motion detection, and video casting, and all of this will be controlled through the use of a Raspberry Pi.
So we'll have the LEDs. So we're gonna be using the Raspberry Pi. So we'll be communicating with the NeoPixel LEDs. So basically, and then the Raspberry Pi will essentially the Raspberry Pi will basically use the Google Assistant SDK to provide voice recognition capabilities, and will basically read the user commands. So I'll pass it down to Saba.
So the IR sensor is going to be connected to the Raspberry Pi through the GPIO. So it's going to basically give out a simple true or false, indicating whether there's a motion sensed or not. If the motion is sensed, then there's the Raspberry Pi will tell the monitor to turn on, and it will transition into a timed loop, listening for the keyword "Hey, hello, smart mirror" for 5 seconds. If that is if the wake word is heard, then the system will transition into listening for a Google Assistant command. Otherwise, the monitor will turn off and it will wait for input from the motion sensor.
So the Google Assistant software development kit will serve as the cohesive layer for the smart mirror. As shown in the system overview diagram below, the Google Assistant SDK will allow for voice control functionality that will allow us to set calendar events, reminders, change the color of the LED lights, and receive weather information. In conjunction, we'll be using the Snowboy hot word detection software to incorporate a wake word that wakes up the graphical user interface display. This allows for less power consumption so that the Google Assistant SDK will not constantly be listening and sending requests.
So in our design, we want the user to see themselves, but also what's displayed on the mirror. So we will be using an acrylic mirror that's 70% reflective and 30% transparent. The mirror will be a 25-inch acrylic mirror that's fitted onto the wooden frame. Then we'll have a 24-inch monitor behind the mirror, and then the monitor will be an HD monitor that has connections to the Raspberry Pi and the built-in speaker.
Thank you for listening to our presentation. We are Team 982, and later today we'll have a booth set up so you can see our demo. Thank you.
I'm confused. What does the mirror do? It doesn't sound like the real mirror. It's kind of a semi-mirror with a monitor behind it.
So it'd still be a mirror where you can still see yourself and things like that, but it would have essentially a basic graphic user interface where you'd still be able to see yourself, but it'd be almost like you would still be able to see information, right? Like it would be kind of like when you swipe on your phone and you're able to see like your control hub of weather, things like that.
It's similar to kind of like AR, where it's an overlay on the mirror.
So the 70% voice recognition accuracy, how does that compare with existing products? It seems low, but how does that compare with existing products on the market?
I would say it is a little bit lower, but I would say that's partially limited right now by the microphone that we're using. And something like your iPhone, it utilizes actually a shield, which is an additional piece of hardware, which we've looked into to helping bump up that voice detection rate, basically because right now we're using a software to do that instead of a hardware component to help listen for that word and help with the recognition.
So question about your microphone. If this mirror is in a bathroom, and a bathroom can be very echoey because of the high ceilings, tile, and other things, how are you going to manage acoustic echo cancellation and voice recognition going on with one microphone?
So right now we've tested the microphone in a couple different environments, with a large room with a lot of voices, and then in smaller rooms, which right now a lot of that can be affected by the gain, but we've also looked into getting a more expensive microphone, like using microphone arrays that can help with echoes and things like that.
Are you considering any privacy issues? Most of the voice control things that we have now don't actually see you. So how would you combat that?
What do you mean by it sees you?
Well, the mirror, it does video casting, correct?
Okay, so the video casting is like, for example, say you had a YouTube video on your phone and you wanted to play that video to the mirror so that way you could see
Okay.
something. So that might have an application in like grooming. If maybe you were watching some sort of tutorial on how to cut your hair or something like that, you could see it in the mirror while also doing it yourself.
I had a similar concern about the voice recognition accuracy because that's frustratingly low.
Right.
But what I'm more interested in here, for your purposes, is how did you come up with that? Did you look at what alternatives were, or was there any kind of look at what users are actually interested in or what they're willing to tolerate in this case? So it's an arbitrary number, unless
Right.
you've got a reason for it being there.
Right, so we've been using, that's basically just from our initial test that we've done this semester with the microphone we currently have.
So that's what you were able to get.
Right now.
Okay.
No, there are other products out there. When I was staying at the Westin in Vancouver, there's some of the bathrooms, they have actually, a TV had CNN embedded inside the mirror. So I mean, this is just your next gen. Is that what you're taking that idea and you're taking it to the next step? Is that it?
Right, yeah, we're trying to add more functionalities and combine them all into one and integrate them into one system.
All right, let's thank you.